Hello, welcome back friends to your channel of learning. So let's continue with the continuity. So in the previous 2 or 3 videos I've given you some basic concepts about continuity, and last video I gave you some algebra of continuous functions. Please go through it if you haven't. Today we're just going to now jump into the exercise and then see how is it actually applied. So without wasting much time, let's just jump into exercise 5.1. Like, question is like, find all the points of discontinuity of the function where f is given by this value. That's question number 6 from the NCERT textbook. So now the previous video comes into play here. That is, like previous video I had given some algebra of functions where in one it is said. So if you let me just finish this. That is like solution for x less than 2, what is going to be my function? And for x greater than 2, what is going to be my function? For x less than 2, what is my function? For x less than 2, my function is 2x plus 3. For x greater than 2, what is my function? It's 2x minus 3. So now you will see that for anything, so in the number line, anything that is less than 2, greater than 2, or all what? Polynomial functions. And last, in the previous video, I have given to you that every polynomial function is a continuous function. So since every polynomial function is a continuous function. So since every polynomial function is a continuous function, there is now only one place where we will have to check about the continuity of the function, that is at the point 2 only. So before 2, after 2, all functions are continuous. So that leaves us with only one point. So we check the continuity. So with the check, we check the continuity at x equal to 2. So let's begin our checking. So first, find out the value of the function at x equal to 2. X equal to 2, we are going to use this 2 into 2 plus 3. So 2 to the 4 plus 3, that's going to be 7. Let's start with the left hand limit. X tends to 2 minus f of x. So that we change the interval, no? That is h tends to 0, something slightly less than 2, that is 2 minus h. So what will be, which function are we supposed to use for anything that is less than 2? 2x plus 3. So that's 2x, that is h, plus 3. So I'll just write, continue here. So that's going to be limit of h tends to 0. So that will be 2 to the 4 minus 2h plus 3. So what will be the value of this? So that's going to be limit of h tends to 0, 7 minus 2h. So now I guess we can remove the value of the limit, that is 7 minus 0, that is 7. So right hand limit also is giving us the same value. So now let's check the left hand limit. Are you done? Okay. So let's check the left hand limits, right hand limits. So I'll just change right hand limit. So slightly more than 2, 2 plus, 2 plus. But we're going to be using this function for anything that is greater than 2. So 2x minus 3. So 2x minus 3. So that's going to be only 1 here. So 1. So if you remove the limit, we have 1 minus 0. So that's 1. So now here, what do we have? Here we have that limit of x tends to 2 minus, and the limiting value as we approach the function from 2 plus. Actually, they are not even same because one is 7 and one is 1. So our function is discontinuous at x equal to 2. So we have got one of our points of discontinuity. So that's what we are supposed to be doing in this particular exercise in this question. So let's move ahead. I think you're done. Let's move ahead with maybe 1 or 2 more questions. That is, maybe let's try 9. A function from the NCERT textbook again, question number 9, that is given to us x by mod of x. If x less than 0 and then minus 1 if x greater than or equal to 0. So let's see whether it is really continuous or not. See, if we just, for x less than 0, what happens is, this is a rational function. Algebraic modulus, we have already seen that modulus function is also continuous. Greater than 0, it is minus 1, which is a constant function. So definitely this function is continuous before and after 0. So the only place where we will be concerned about is at x equal to 0. So let's check at the point x equal to 0. I hope you've got my point there. Now because before x to a function to x by mod x, which is a rational function. Last video we covered now rational functions when you have two continuous functions of the form p by q, that will also be a continuous function. And then this is minus 1, constant function. So this is already going to be continuous. Now our concern will be at the point 0 only. Please do check the previous videos. All the theorems are given to you. So let's check the function at x equal to 0. So at x equal to 0. At x equal to 0. So f of 0 is minus 1. Limiting value as x tends to slightly greater than 0, f of x. We don't have to do anything here because for any function that is greater than 0, it will always correspond to kiman begin as a minus 1. So we have now just one option left, that is what about as it approaches 0 from the left hand side, that is something slightly, when we change the interval, slightly less than 0, that is 0 minus h, slightly less than 0. So that's going to be limiting value as x tends to 0, f of minus h. Okay, I'm going to rub this off, f of minus h. So what will be our function here? That is slightly less than 0, we use this function. So that is going to be limit of h tends to 0, h, that is minus h by mod h minus h, isn't it? So that's going to be what? Limiting value as h tends to 0 minus h by h, because mod of minus h is h. So here this value is going to be what? This value, so that's going to be limiting value as h tends to 0 minus 1. So that's going to be, of course, minus 1. So now here one thing you will see that all the functions here are corresponding to the same value, minus 1, minus 1, minus 1. So that means here what will happen is there is actually no point of discontinuity. Okay, there is no point of discontinuity. So the conclusion we will write something like this: since limiting value as x tends to 0. Okay, if you want to write separate, no problem. Okay, it's all you want to write directly only for limit also you can. F of x is equal to f of 0. There is no point of discontinuity. Okay, so that is it. Let's try another question again. Maybe let's try 11. That is, our function here also is given to be x cubed minus 3. X cubed minus 3 if value of x is less than or equal to 2, is it? And x squared plus 1 if x is greater than 2. So here also the same problem, same concept, that is before 2 and after 2, that is when x is less than 2 and x is great, not necessary to write, but it's better, yeah, it's up to you, no, x greater than 2 to be more clear with what you write. What happens to our function? Our function is for x less than 2, our function is x cubed minus 3. For x greater than 2, what is our function? Our function is x squared plus 1. So both these functions are what? Polynomial functions. So that means before 2 and after 2 the function is continuous, because both the functions are polynomial. So maybe I'm not going to write, you can just write down, I'll dictate that for you. So that is, since you can write down, since both the functions are continuous, since both the functions are polynomial functions, so they are continuous functions. Got that? Since both the functions are polynomial functions, they are continuous functions. So we check the continuity. So we check the continuity at x equal to 2. So we check the continuity at x equal to 2. Now let's begin. So at x equal to 2, first let's find out the value at equal to 2. X equal to 2, we're going to be using this 2 cube minus 3. 2 cube is 2 to the power 8 minus 3. We're not getting 5. Let's go for the right hand limit. X tends to 2 plus. So that's going to be what? Limit of interval h tends to 0. That is something that is slightly greater than 2. So greater than 2, we have to use this x squared plus 1. So limiting value as h tends to 0, 2 plus h squared plus 1, no? Because it is going to be in the value of x. So okay, if you want, we will just expand quickly. 2 to the 4 plus 2 to the 4 h plus h squared plus 1. If we just expand, now if I can just put the value of the limit, that's going to be simply 4 plus 0 plus 0 plus 1, that's of course 5. So that problem also solved. So that is also same so far, fine. So now the only option, if it is discontinuous, done. Okay, so if it is discontinuous, maybe at from the left hand side, 2 minus. So if function of course does change, that is 2 minus. So that's going to be 2 minus h whole cube minus 3. 2 minus h whole cube minus of 3. So let's find out. So expand. What was the formula? I'm just going to rub this off now. So cube, limiting value as h tends to 0, that is going to be a cube. Okay, I'll just write a cube minus 3 a square b. Some of us may have forgotten. B square minus b cube minus 3. So limiting value of h tends to 0, that is 8 minus 2 to the 4, 4 to the 12h plus 3 to the 6 h square minus h cube minus 3. Just to be sure that we don't get 0 by 0 or something like that, no? Simplifying actually. So now I can just put the value of the limit h, that is 8 minus 0 plus 0 minus 0 minus 3. So here also what do we have? We still get the same value, that is 5. So now we can conclude, so here also we can just write, that is limiting value as x tends to 2 plus from the right hand side is also equal to the value of the function of the limit as we approach x. From the left hand side is equal to value of the function at 2. The function is continuous. You can write down the function is continuous. And you can conclude, so there is no point of discontinuity. So there is no point of discontinuity. There is no point of discontinuity. So that's what we will be doing. Alright, so maybe we can just try another one that's maybe okay. I think that should be enough for you. So please go through it, practice properly. Maths is always easy, it's just up to our practice. Alright then, so still then, see you in the next video. In the next video we're going to be doing some more problems on continuity again before we really jump into differentiability also. Okay, alright then, till then, bye bye, take care, see you.